let's have a look at probability tree diagrams. So I'm going to first write out the 3 things you need to know, and then we'll discuss those. Okay, so these are the 3 things you need to know. So the first one, multiply along the branches. And by branches I mean, so probability tree diagrams look something like this. And these are your branches. So if you want a probability at the end, you multiply along the branch, you multiply this one by this one, or this one by this one, or this one by this one. So multiply along branches, we'll see that in an example. Where the branches meet, the probability adds up to 1. So as we can see, the branches meet here, so these 2 probabilities here will add up to 1, as will these 2, and as will these 2. So those 2 will add up to 1, and those 2 will add up to 1. And the final one, the n probabilities add up to 1. So these here, here, and here, and here, if you add those up, they should equal 1. Okay, so they're the rules, so we're just going to do an example now. Okay, so Doritos collision, chili and guacamole. So I have this bag and I take one at random, I note the flavour, so I say if it's chili or guacamole, then I put it back and it's asking me to find the probability I get 2 different flavours given that there are 32 chili Doritos and 24 guac Doritos in a pack. So the first thing I want to do is how many are in total in the pack. So there's 32 chili and there's 24 guacamole, so there's 56 Doritos in the pack. So I'm going to start here in my tree diagram. I'm going to go like this. So that's if I get chili, C, and that's if I get guacamole. So what's the probability that I get chili? I write along this line here. So that is, there are 32 out of a pack of 56. So there's 32 chances I can get it out of 56. What about guacamole? There's 24 in the pack of 56. So that is the equation from the probability video. The number of ways I can get the outcome divided by the total possible outcomes. Okay, let's keep going. So I then put it back, I make note, put it back, and I pick another one. I do the same thing. So again, I'm either going to get chili or guacamole, and we've worked out the probabilities, so we can write these on. Okay, so that's my completed tree. What was the question? It was find the probability I get 2 different flavours. So that is chili then guac, or guac then chili. So I want to do these 2, so if I get a chili and a guac, and also means multiply when talking probability, and this is rule number 1, multiply along the branches. So chili guac was 32 over 56 multiplied by this one, 24 over 56, which gives me an answer of 12 over 49. Or I can get guac, so I go along this side, then chili, so multiply along the branches. Okay, so now I can either go have that option, so chili then guac, or I can have this option, guac then chili, and because it's an or, in probability, or means plus, so I can get that one or that one. I do 12 over 49 plus 12 over 49, and that gives me 24 over 49, which is rounded probability of 0.49. Almost a half, but not quite. So I hope that is clear. So that demonstrates multiplying along the branches. And then at the end, if you've got 2 probabilities, you want to add them up. If I added up all of these, they should equal 1. So we're going to do another example. Okay, so this bit here stands for, so I've got the probability I exercise is 0.4, and the probability I do no exercise in a day is 0.6. The probability I exercise, then I eat chocolate is 0.7. The probability I don't exercise and then I eat chocolate is 0.4. Finish my tree. Okay, so first of all, what goes on this line? This line would be the probability that I exercise. So yes, that's given to us in the question, that is 0.4. Probability I don't exercise is also given to us in the question, but we could also work that out because we know that these two here, where the branches meet, has to sum to 1. So it would be 0.5, 0.4 plus x equals 1, so x would be 0.6, which we know, but yeah, just so you know. And now let's read on. So this line here, is that I exercise, then I eat chocolate. I was given that probability I exercise, then I eat chocolate. So exercise, then eat chocolate is 0.7. The probability I don't exercise, then eat chocolate. So no exercise, then eat chocolate is 0.4. Okay, so we've used everything in the question, but we still have blanks. And we can work out those blanks because we know that these two here, where branches meet, sum to 1. So we know that 0.7 plus x equals 1. So x equals, take that over there, it's plus 0.7 here, so we take it away, 0.3. So that is 0.3. And here we have the same thing, 0.4 plus y equals 1. So y equals, rearrange, take that over there, it's plus 0.4 on this side, so we do the inverse, minus 0.4 on that side, and that would be 0.6. And then we have our completed tree. So this is now higher level stuff, and this is the at least questions. So I'm going to write down an example now. Okay, so I'm going to show you this in an example. So here I have a pack of cards, I pick one, then I put it back, and I do this 3 times. What's the probability I get at least one ace? So first of all, how many cards are there in a pack? There are 52. If you can't remember that, just do 13 times 4 because you know there's 13 of each suit. Anyway, so the way you do probability of at least questions is you say that is the same as 1 minus the probability of less than that happening. So that sounds confusing. Let's put it into this example. So I've asked, I want the probability of at least 1 ace. So that is equivalent to 1 minus the probability of what would be less than getting 1 ace would be no aces. Okay, so now I want to find the probability of getting no aces. So the probability I don't get an ace the first time is, so if we think of a pack of cards and I probability of no ace, there are 4 aces. So there are 52 minus 4, 48 other cards I could get that aren't aces out of the 52. So these are the number of ways that could happen over the total possible outcomes. So probability of no ace is 48 over 52. But I'm doing that 3 times, so I could use a tree diagram. So I could go probability of getting an ace, probability of getting no ace, probability of getting an ace, probability, I'm going to call it NA, and that is the same because I replace it. Do it one more time, the third time. Okay, so the probability of getting no aces 3 times is no ace, no ace, no ace. So along the branches I know I multiply. So we have 48 over 52 multiplied by 48 over 52 multiplied by 48 over 52, which gives me, if I round it, 0.79. I shouldn't really round it yet, but we're going to go with it. So then the final answer would be the probability at least 1 ace is 1 minus the answer you get here. So mine wasn't quite that, but I'm going to go with that. So that is 0.21. Okay, so Amy goes to the fair, and then I've really kind of briefly summarised this. This is the probability that W wins Hoopla is 0.4, and the probability she wins Coconut Shy is 0.3. Complete this tree diagram. So this is the Hoopla column, and this is the Coconut Shy column. So it's done one bit for you, and we can work out this bit, because we know that where the branches meet, it sums to 1. So 0.4 plus 0 point something gives you 1. And that would be 0.6 if you take that round there. Okay, same thing here, we've got a 0.3, let's call this y, so y equals 0.3, that's not correct. So y plus 0.3 equals 1, so y equals, take this over, 1 minus 0.3, which is 0.7. We also know that here, this is the same thing as this one, this branch here is her winning Coconut Shy, which we've been given in the question. Probability she wins Coconut Shy is 0.3. And the same thing here, the probability she doesn't win is then 1 minus 0.3, which we just worked out there, 0.7. So there you've just completed the tree. So here we have, Hannah has 20 biscuits, 12 of which are plain, 5 are chocolate, and 3 are ginger. She takes 2, and this means she doesn't replace them, otherwise it would have to specify that it was replaced. What's the probability that they are not the same? So this is one of the at least questions. So probability of not the same is the same as 1 minus the probability you get 2 the same. Okay, so now let's work with probability you get 2 the same. So that would be the probability of getting a plain one and a plain one. It would be the probability of getting a chocolate and then a chocolate, because that would be the same. Or the probability of getting a ginger and a ginger. So let's work them out. So the probability she gets a plain chocolate biscuit is 12 out of 20, because there are 12 ways you can do it, and the total outcomes are 20. But then she's going to get 1, and she needs another one. So and is multiply in maths English speak. Now there aren't 12, there's now 11 because she's eaten 1. So there are now 11 plain biscuits out of the 20. And if you just, pop that in your calculator or something, you get that. So what about the probability of getting a chocolate one followed by a chocolate one? So probability of getting a chocolate one initially is 5. The number of ways it can happen over the total possibilities, 20, and then the second, oh, I've messed up. That should be 19 because there aren't 20 left. Sorry about that. Don't make that mistake, that's very important. So here, so that now she has 5 chocolate biscuits out of 19 because she's also eaten a biscuit, and that would give you 20 over 380. And then probably she gets a ginger and a ginger, so there are 3 gingers initially. Then there would be 2 left because she's already taken 1, and 19 biscuits left because she's already taken 1. Okay, so now we have to sum all of those up, because in maths terms, OR means add, and the way she can get 2 the same is by doing that, or that, or that, so that means you add them up. So if you add those 3 values up, you get 158 over 380, and then don't forget the final step, that is this bit. So you must remember to do 1 minus your answer, so 1 minus 158 over 380 equals 222 over 380. So there we go, that's an example of a slightly harder question. This one obviously reduces, but don't forget to reduce that one. Very important factor there, because it hasn't specified that she replaced this one.